And so it's kind of hard without actually looking at it and seeing all this stuff. Really begin to understand it. And I've got all these parts. This is why, if you look at this all these structures, that we're going to get what they say is the labyrinth. So now, once we have this outer ear, the outer ear is going to go all the way to our eardrum, this little portion right here. And then we begin a section that's known as our middle ear. All right? Now, the middle ear, which is like here, right through here, this area where I'm trying to point to. Well, this is going to be our tympanic cavity. So they're saying that we've got this cavity right here in this temporal bone. Well, the eardrum, also known as the tympanic membrane. Okay, so this eardrum, what it begins to do, it helps to create the separation from our outer ear to the middle ear. So we begin to find at this point our innervation. Now, the only way that they're kind of showing the innervation here is by this little structure right there. But it's much more than that. Okay? But the pictures will kind of show it a little more. But this would be our innervation that's coming in to the ear. We have our vagus and trigeminal nerves. We're going to also find that we're going to have some other cranial nerves coming into this area. Do you guys remember the vestibulocochlear? Okay, that's going to be coming to a part of our inner ear. So here for the middle, we're going to have the vagus and the trigeminal. This cavity continues into what we call the mastoid process. All right, do you guys remember the structures? Okay, so it continues into the mastoid process by way of my eustachian tube. This tube, this pharyngotympanic tube, is another name for it. And do you happen to know what that purpose is for that tube right there? Or why there might be problems in children with it?
Like if you got fluid in your ear, or unnecessary fluid, like I guess get rid of it.
And do you know what they usually do to do that for children and stuff?
They put like a tube in there.
They put the tubes in. Because in children, see how this tube is kind of like doing this number, okay? In children, it's pretty much straight. The ability for it to drain correctly isn't there yet. Not until they grow up a little bit. And so it does become an area for ear infections, lots of problems, and they usually go in and put little tubes in to try to help it drain so that the child doesn't have as many ear infections and so forth. Now, in this part, one of the things we're going to find, we do find air. This tube begins to make its way to part of the nasopharynx. The goal, help to aerate and drain the middle ear and equalize air pressure. You get on a plane, for example, you begin to ascend or descend, and what are you doing? and chewing gum and doing all this sort of stuff to try to pop those ears. And the goal is to equalize that pressure. Otherwise, it's very painful. Have you ever felt that pain? Think about the children who are on board that plane and can't do that themselves. That's why they're crying, because that is massive pressure and pain on their ears. You know, people should be like, hey, can I help? You know, because trust me, I'm sure that child is crying because that's some pain, you know. So we've got the outer ear, middle ear, and as we continue to move into the structure, we'll get to that inner ear. So this is pretty much what we're seeing. The biggest thing that we're missing are some of the nerves, being able to see those full nerves. But our outer ear, inner ear, this is the portion where we meet outer to inner. These are the 3 smallest bones of the body. Yeah, they are part of the 206 that we have. So we've got our stapes, incus, and malleus, the hammer, the anvil, the stirrup, okay, is usually how some people refer to them. But where they're located is where it begins to get interesting. If we take a peek at these bones, all right, first thing I have right here, I have a membrane. This membrane right here, those air molecules that are going to be coming into the ear based upon those movements, the frequency, okay, they're going to have the ability to come and hit this membrane. So what do you think is going to happen when they kind of bump, move, hit into this membrane?
Vibration.
We're going to see it move. Now, take a peek at what's attached to that membrane. We've got a bone. And that bone is attached to another bone held by a ligament in the ear, attached to another bone, meeting an area in my inner ear. Okay? In my inner ear, I begin to see some other structures that are present. I'm seeing, I got some semicircular ducts. I've got an oval window that this stirrup, because that's what it looks like, okay, makes a direct connection to. Is everybody kind of following me? So now that's making a direct connection to these parts that are in my inner ear. So that vibration gets to come in, move the bones, and this begins to now knock on that oval window. And the structure that you find for these parts right here are going to be the reason that we're going to get sound and then have the ability for the equilibrium. And attached to this cochlea and those semicircular ducts was my vestibulocochlear nerve. So now I've got the connection to the areas of the brain to make sense out of that information coming in. So, is everybody kind of following me to this point? So, yes, this inner ear, most definitely a maze, all right? So we begin to take that out, all right, put it back into the bone, and it looks like you can see all these pathways, all these mazes, places, okay, in the bone. So this inner ear portion, okay, we're going to have connected to it, which is not a very good representation, but I'm going to have my vestibulocochlear nerve, okay, because I got two parts. Remember, this is a two-part nerve. One part to go to the vestibule, one part to go to the cochlea, because I've got my cochlea, the snail portion, and I've got my semicircular ducts with the vestibule. What's a vestibule? Ever heard of one? Okay. It's an entryway before you enter the official building. So you would, a lot of churches have them, the vestibule, and it's the area that you walk into before you officially walk into the building. That would be a vestibule. This is what they call the area at these semicircular ducts. And that's where part of the nerve is going to be connected, and the other part to my cochlea. So this internal ear, yes, we have the maze in that temporal bone. They do refer to it as a bony labyrinth. We now encounter membranes. We're going to find these membranes. We're going to have a portion between what they call the bony and the membranes, and the fluid you find there is peri-lymph, so meaning to the outside fluid. Okay? Then inside the membranes, meeting the other parts of the ear, is endo-lymph. So if we were to take the cochlea, the snail portion, and roll it out flat, outer part peri, innermost endo. Okay? We're looking at pretty much a tube within a tube, because of the way that we are going to get a separation for the fluids. So like if we were to take this cochlea and stretch it out, peri is to the outer portion, endo to the inner. Is everybody following me? So in my semicirculars, the same thing. So I now have fluid and fluid in these structures. And it's from the fluids we're going to be able to have contact with those nerve fibers. So in looking at contact with those nerve fibers, if I'm looking at my cochlea, to the outside is my peri-lymph. To the inside is my endo-lymph. But let's take that portion, blow it up a little bit. Now, in my endo-lymph, did you notice the connection to nerve fibers? So that's how it would be structured, all the way around that coil. That structure you see right there would be structured and lining every coil.